Okay, so it's recording. Hi, this is the talk for an introduction to serverless architectures. I'm Steve Mustafa Dafer. You can check my profile here, my LinkedIn. You can contact me on Facebook. I currently work with SOTI. SOTI is the world leader in business mobility. I work on the cloud team, and part of my job is to work with serverless functions and architectures. I graduated a couple years ago from Dalhousie as a computer scientist, and originally graduated from Rafiq Hariri University back in 2014 as a computer and communications engineer. Yeah, so enough about me. So our talk is about serverless. Anyone would like to tell us what they think serverless?
It's basically you don't have to manage servers. You can just write your code and then that's it.
Right, to a huge extent, yeah. Anyone would like to add anything? Okay. So the server cannot crash if you don't have one, right? That's not totally true, and we'll be discussing that in a minute. Like our friend said, services, you are managing services rather than having to manage virtual machines, for example, databases and their fault tolerance, scaling, and so on. Now, there is still a bit of scaling, which we're going to talk about, but for the majority of things, you'll just be dealing with your code directly, like you just write the code, and that's what really matters. So this is compute. It's computing by executing your functions. There's data, which is databases, for example, and throughput and queues and so on. So you care about your data, but you shouldn't care too much about where it's being stored, how it's being stored, the details of scaling, and so on. Again, there's still scaling, and we'll see it in a minute, but it's not as complicated as doing everything by yourself using VMs and unmanaged databases. There's AI services. AI services are different from you having to write your own code or variation of a specific algorithm, for example, by the host providing you with a ready-made solution, and you just tweak some variables and along with other things. So we'll see some of these other things later. So with serverless, we call functions rather than containers and servers. Like our previous talks, for example, we talked about microservices and how you create the API, how you still have to host the API somewhere in probably in a VM. You still need to care about the database you choose. We also had another talk about how to choose a database. So yeah, so in here, you really just care about the functions and the actual code rather than how to manage containers and servers and so on. So these functions, your functions, are going to execute on event triggers, whether it is a trigger from another function saying, hey, I finished my task, whether it's time-based, whether it's an HTTP request, whether it's a message, a real-time message, and so on. And as for payment, you only pay when the function executes, while it executes. And the function scalability to a certain extent is auto-managed. What this means is, remember the cliche thing about the cloud like 10 years ago when they said pay only what you use. It wasn't really pay what you use. It was a huge improvement over the dedicated servers or even the shared servers at the time, but you still had to pay for a virtual machine all the time as long as it's deployed, even when no one is accessing your solution, right? So the difference here is you won't even pay based on a duration that your functions are not running. So you only pay while the code is running. So I know it's still a bit vague, but we're gonna go into the details. The takeaway of this slide is you'll be caring more and focusing more about the code you write and how the data is going to be manipulated, rather than caring about hosting, containers, servers, scalability, fault tolerance, and so on. Even though to a certain extent, we're going to talk about fault tolerance and scalability in serverless solutions. Now, motivation, is it motivation or hype? Like, do you really pay for only what you use or not? And an excellent example is the Australian census. Back in 2016, Australia decided to make the census digital. So people would log in online and vote. And so they partnered with IBM, which created custom hardware just for the census, and the solution cost them $9 million. And it actually failed. They released it on a Friday evening. I'm not sure if it was a Friday evening or a Thursday, but they released it on an evening, and everyone tried to connect at the same time, and it had the effect of a DDoS attack. And basically it was a failure. So a couple of students later on, the next week, they were participating in a hackathon, and they had this idea that what if the census solution was built using serverless architecture? And by actually running load testing, they reached the conclusion that for only $500, they were able to get, I think, four times the capacity that the $9 million solution could accommodate. If you're interested to learn more about this, you can go to this link. Yeah, so we're going to have cons and pros of serverless. I'm not saying serverless is the solution for everything. From now on, never use anything besides serverless. It's not like that. But definitely there are use cases which will save you lots of money and lead to much better performance. So in previous talks, we discussed Monolith and microservices. Just a quick reminder, Monolith is where you have everything interconnected. So the user interface is directly connected to the business logic, and the business logic is directly connected to the data access layer. And then you have a database which serves all your data. Could be more than one database, but that's generally the concept. While in microservices, you have the user interface which connects to many different microservices. So instead of one service which serves all functionality of your app, you have a lot of them. And if one fails, that's fine. The rest will still be working because they're not interdependent. And each of them can have its own database. Okay, so if you want to learn more about microservices, you can go to this link. And this is the Netflix architecture. Yeah. So you can see how they have tons of services interconnected. Like, for example, in Netflix, the recommendation system, which recommends movies for you, that's a microservice. For example, the series recommendation system, the payment system, the movie player, each of these is a microservice, and it's estimated that they have around 700 microservices just in Netflix. And this is a little bit old, so I'm pretty sure they have more. Yeah, so that was for microservices, where you split your code into smaller parts and make them their own entities talking to one another using APIs. So now, introducing serverless in our talk, this is the difference. So Monolith, you have a front-end, back-end database. Microservices, each feature has its own service, which could be written in a different language, could be Dockerized, could be managed by Kubernetes, and so on. In serverless, you don't even have to care about that because you simply write the functions. So for example, this is our client, and there's an authentication service which just basically logs them in, maybe gives them some permissions and so on. And they go through an API gateway. This is very similar to the router in any API. So this is just a router. The user goes inside their browser or sends up a request, some kind of RESTful request, which is received by API gateway. Now, API gateway is a service provided by your host, and the API gateway will trigger one of your functions. So what you're actually coding is the function itself. So you tell, let's say Azure in this case, because our talk will be focusing on Azure. Let's say you're using Azure functions, and you create a new search function. So the API gateway will trigger this function, and this function will run. And this function could be using, for example, the product database. It will then return. The return of the function will be the actual data that's going to return to the API gateway and then to the client. Same thing for another function, which is the purchase function. So you do all the coding of this function, and then it connects to a database, and then it returns the result. Yeah, what I'd like to say here is that the database could be managed as well. So you have a minimal worry about scalability and fault tolerance. This is an example serverless application architecture. So the user accesses our web app, and the code is hosted in S3 bucket. S3 is a binary or blob or file storage service provided by Amazon. And so the files for the front end are stored in, and then using the front end, the user is making a request, RESTful request, let's say, and they go through an API gateway, which then trigger a Lambda function. This is an architecture from Amazon. So Lambda functions are the same as Azure functions, but Lambdas are on Amazon, whereas Azure functions are on Microsoft Azure. So the Lambda function runs some code, accesses a database, does something, and returns the result back to API gateway, which forwards it back to the user. Pretty simple, right? So now for serverless, what are the pros? What are the cons? Until now, I've been just showing you the pros. So pay for what you use. So as long as the function is running, you're paying. If it's not running, you're not paying. It's pretty scalable. It's auto-managed, actually. The next slide is about scalability and fault tolerance in serverless. So we'll see how to actively increase scalability or optimize scalability and fault tolerance. But even if you don't care about that, it is the maximum, like it's managed. So lower cost, because again, we talked about the Australian census as an example. You focus on the user experience. You don't have to focus on the servers, on the scalability, and so on. You're really just focusing on the actual code and thus the user experience. Now, the cons, you are locked into the vendor. So if you're using Amazon services, it's difficult to switch to, let's say, Google Cloud or Amazon or Azure, because you'll be using services that are directly provided by the host themselves, and moving requires a lot of work. There is a learning curve because, this is not the norm which is taught at universities. It's unsuitable for long-term tasks. That means that if your functions are going to be running 24 hours a day, then the cost is unjustified. The cost is going to be higher than using a virtual machine, for example, or a container-based architecture. So this is meant for micro function where each function has a time limit of execution. Some vendors even enforce limits. I think Amazon, for example, enforces 25 minutes, and then it just turns off the function if it goes beyond that. Yeah. So any questions? Is it clear, the cons and the pros?
Yeah, I have a question regarding this.
Sure.
So it makes sense, like the serverless makes sense to use in the backend perspective, like creating APIs and endpoints, that is fine. But from the front end point of view, let's say you use, as you explained before, if you use S3,
Yes.
but S3 has a limit, let's say something like 5,000 requests or something. I'm not sure about the exact number, but it has a limit which says approximately 5,000 requests per second or something. So in
Yeah.
that case, how is it how is it scalable? I mean,
Yeah.
it is serverless, but
That's an excellent question. And I was going to look up something because I thought you were going to ask about something completely different. The answer to that is using something like a CDN, which this is the example we're talking about. So you use a CDN which connects to multiple sources that provide the blobs and the static content.
so will the CDN have the entire that build file of that front end? Like, will the CDN have that cached somewhere, or I'm assuming that CDN will cache the frequently accessed files.
Yes.
So will it cache the, like, let's say you have a React application or something,
Yeah.
and you build that and you've put all those JavaScript files and a single HTML file somewhere
Yeah.
in S3 bucket. So will CDN cache this entire thing so that the entire application is
So this
there,
really
or
depends on the settings and the structure you decide to go with. Like it doesn't, when we say it's static content, it doesn't mean it has to be all of it in one file. You can still have your own CSS files on their own, your own HTML files, your own JavaScript files, and so on. And then you have a single HTML file which combines everything together, or more than one HTML even. And then it's up to you how you decide on the CDN caching. So it's up to you how you decide to cache your files. It's up to you how you decide to combine or separate your files. The thing is, at the end of the day, you really only need the link to the file, right? And this link, you can have a single HTML file cached in Azure CDN, for example, or even in your S3, which is loaded by CDN, and then it loads the other files. Is this what you're asking about?
Yeah, so over here, there's no need to create like that Lambda function or any functions over here, right? For front end point of view.
No, front end has nothing to do with Lambda functions. Serverless architecture is for the backend, not for the front end in the first place.
Got it. Perfect. Thank
Yeah,
you.
for front end, the front end is static. Even if you update it or you need to refresh the cache, the content itself is static because the
Yeah,
dynamic content is loaded by the backend, right?
correct, correct. Yeah, so that was my first question. It made sense to use Lambda functions and the serverless for backend, but it
Yeah.
did not make sense for.
Yeah, no, it's not a front end thing. It's a totally back end thing.
Yeah.
Yeah, this is actually our current slide. So so in this slide, I meant to show you how we scale and provide fault tolerance. So this is an example on how to scale a Lambda function or a serverless API, to be clearer. So this is how you scale the front end, which just static content and blobs and files. And then you could use Azure Active Directory for authentication. You could use the Azure DNS, which will route to HTTP, like link your domain and so on. And then you could use Azure Front Door. Azure Front Door is, you could think of it as an equivalent to a load balancer to a certain extent, but it's a service, not a server. So it's not really a load balancer. It's a service provided by Azure. And then this service decides which region to go into. It could be based on the nearest region to the requester. It could be based on an active passive region, which means if one region is down, then it goes to the other region, and so on. And so the same thing could go with your managed databases. So your app service plan is the plan you purchased, and it determines how much RAM you get, how much resources you get, and so on. Then this plan, from this plan, you assign a queue so that no DDoS attack happens. If there's a lot of traffic, then the traffic will be queued in here. And then one by one, like it doesn't have to be one by one, but could be a limited batch. So you can say every 2 together, every 5 together, every one, or each one alone, and so on. You can decide how the queue works. And then it goes to your function, and then your function talks to your databases. You can have a caching for the databases, for example. This is very important to my tech innovation course students. If you have any questions, this is the bonus point question I'm asking for. And that is if you're using serverless. If you're not using serverless, the architecture would look something like this. You have a traffic manager or a load balancer. You have different VMs. Each VM has one or more databases, and so on. So any questions before we move on?
So the queue over there is to limit the concurrency, right?
Yes.
Okay, got it.
And just a quick note, because I saw some of my students doing that. Some students used Kinesis instead of queue because Kinesis does have, yeah. And that's actually not like, it's good that you're trying. That's the best thing ever. You always have to try, right? So the thing is, Kinesis is a full-fledged solution for semi-real-time communication with data retention. And if you want to simply limit the concurrent requests, you don't have to use something full-fledged for a completely different problem. The solution to your problem is a simple queue, which would actually cost you even less. So yeah, just as an, okay, next slide. So fault tolerance. So I just wanted to show you this, and just remember that I always include some references. So if you're interested in learning more about any idea I'm giving you, then you can go to the references. This is availability. Like imagine someone telling you, I can provide you with 90% availability, which sounds pretty good, right? But in actual numbers, per year, your service is going to be down for 36.5 days at 90%. If someone tells you, oh no, we can provide you with 99% availability, which is pretty awesome, but it boils down to 3.65 days downtime per year, which is pretty bad. Um, then you get, so from normally, or generally speaking, from serverless architectures which are not scaled in this manner, like you just use the function with a simple queue and that's it, the availability, generally speaking, is 99.95, which is 4.38 hours downtime a year. So imagine if you have 1,000, if you have only one request per second, imagine how many requests you're going to be turning down and how many customers you're making angry. So with better fault tolerance and scalability, you can reach, let's say, 99.9, and that's 31.5 seconds. Can you reach 100? The answer is yes. That's what we really call fault tolerance. However, it's not guaranteed, and it's going to cost you a lot. And that's why you will never, like, at least until now, we do not have any host that can guarantee you 100% availability. But can you reach it? Yes, using something like this with many different regions, with many different replication, a lot of replication and so on. But again, it's not guaranteed. So again, back to the definition. What if I told you serverless runs on servers? So this is a contradiction to what we saw earlier. If the server cannot crash if you don't have one, now we know that it actually can crash. And that's why we use different regions, because maybe in one region there's a fire in the data center, for example, there's a flood, there's a power outage for some reason, and so on. So it's actually running on servers. We need to make sure we do understand that. But serverless still has servers. That's not the point. The point is you do not have to manage these servers and their granular scalability and so on. Now, hot versus cold start. So there is something we call cold starts, and cold starts is when we run the function without it being deployed. So as we said before, you only pay while the function is running. So when the function is not running, there is a chance that it will be no longer deployed. And the next time you make a request or trigger this function, it's going to be deployed first, and then it will start executing. And this is what we call a cold start. A hot start means you called it while it's still deployed. So all that there is to it is to simply execute the code. While with a cold start, you need to deploy it first. Of course, it's not manual, it's automatic, but it will take some time. So it will add some delay. And we can see in Azure C#, for example, it could take up to 4.5 seconds before the code of the function starts executing, which means that you need to cater for this delay, especially with time-critical tasks or requests. So is it clear? This is a diagram that shows you how long it takes to deploy a function in both Azure and AWS based on the language. Because in serverless, you can write the function in many different languages. So, and not all functions have to be the same language. You can write one function in Python, another in Go, another in JavaScript, and so on. You can even have a polyglot with hosts. So you can have one function in AWS, another function in Azure, but then that's complicated because you need some kind of middle service which knows where to route. But that could, like, it is possible. So anyway, is it clear what hot versus cold start is? No? Yeah?
Okay, so someone during my last, this is a repeat, we're repeating a previous talk. So someone asked about how it actually works, and I had to draw this quickly in Paint for them. So please excuse my painting skills. So this is your function. It gets deployed to the server, and then it starts to execute. This is the time while it's deploying. You do not pay for this. You pay for the time while it's executing. It finishes execution and returns the result. It stays, so this is an example from Amazon. It stays deployed after it finishes for 25 minutes. So after 25 minutes, it will be removed and it will need to start coldly again. If you have another request within 25 minutes, then it will run directly because it's still deployed. You don't have to wait for the extra 5 seconds as an example. And the 25-minute counter resets. And this is why now we have, it used to be the case where we would create a specific condition just to keep it warm. So we would, every, let's say 5 minutes or 10 minutes, we would send a request just to keep it warm. And now this is done automatically by some hosts. You can just choose it in the setting where they will make a certain request to keep it hot. All clear?
I have a question.
Sure, go ahead.
So first of all, do we pay for this 25 minutes?
No, you only pay for this time here, the duration it's running.
Okay, then the second question is, let's say you keep this hot and you keep this running for 25 minutes, and within the 25 minutes at the same time, 2 requests come in. So do we create one more function, or?
This is automatically done for you. So you only create the code of the function, and then
So I was asking, let's say 2 or let's say 10
no, it's
requests
still deployed.
come in.
It's still deployed.
Yeah, so 10 requests come in. So would it run on the same hot function, or do we create new
same hot
functions?
Function. The hot function is actually a deployment. It's not just one function which is synchronous. So the deployment of the function is what causes the cold start. So if you receive 10 requests at the same time and the function is cold, all 10 requests will have to wait for 5 seconds for the function to get deployed, and then the 10 requests will run in parallel, and the deployment will still be there for 25 minutes. If you receive one request on a cold start, this one request will have to wait for 5 seconds, and then it finishes, but it's still within the 25 minutes. You receive 10 other concurrent requests, but it's still hot, so they run directly.
Okay. So if I understand this correctly, a function is like an entire application itself, a mini application, which can handle multiple requests.
Yes.
Got it. Okay, thank you.
You're welcome. Any other questions before we move on? Just keep in mind that this is improving. Like, I don't even know, maybe this is outdated now. I don't know, to be honest. But the thing is, providers such as Microsoft, Google, and AWS, and so on, they are trying to make the time for cold starts less and less. So it doesn't mean that Azure is bad. It means they're both working, and it really depends on your use case.
I have another question.
Sure.
Sorry for interrupting.
Yeah, sure.
So let's say I deploy one entire Node.js or Express.js application as a function, as an Azure function or as a Lambda function. Will that be okay? Like, is that a good practice? I know I can do that because I did it.
Yeah.
But is that a good practice?
It's definitely a bad practice. And the reason is, these functions are supposed to be micro. With microservices, you can think of it as nano, but this is not a real term. I'm just coming up with it.
It is like a microservice. Let's say it is like a small application with 10 APIs in it. So
that's the problem. That's the problem. So you'd be better off containerizing it. So if you make a Docker out of it and containerize it, that would cost you less. The main thing here is to remember 2 things. One, if you go over 25 minutes of continuous running, then it will be blocked. It will be terminated. And so there's a time limitation. Plus, it's much more expensive. So if you containerize it and run it as a microservice, or even just as a container using the cloud, it would cost you less than running it as a function.
Oh, okay.
You see what I'm saying?
Yes, yes.
Because after all, it all boils down to cost, right? Like even if you have a monolith can be scaled. Like what's the worst case scenario? I'm gonna spin a new virtual machine per request. I'm gonna keep an additional virtual machine per request. I can do that. So, but it's gonna cost me like it's gonna be disastrous, right? Anything can be scaled, but it really boils down to the cost and to manageability, how easy it's to manage. Does that answer your question?
Yes, yes.
Okay. And I'm going to show you some code. I know we're running just a little bit late. I would have liked to start coding at 1:40, but that's fine. We even started late, so please bear with me. Yeah, so this is an example of an actual service cost per month. It only cost them $1.6 per month. Whereas if they created a virtual machine with a full-fledged API, it would have costed like a minimum of, let's say, $10 per month with all the resources from hard disk, from the VM itself, whatever costs are related. So in this case, you can see a breakdown of the cost, and you can see more details. Like this, the case I'm showing you is for a middle, what was it? Low to mid? Yeah, low e-commerce solution. Sorry, where's the, yeah. So this is the link. I just opened the reference and you can see other examples. So this is for a high load solution and it's costing them 400, let's say $80 per month. And while this may seem a lot, it would be even more if they were using a VM with load balancer and replication and so on. Of course, that is given that serverless is good for their use case. So you can see some examples here with price breakdowns and so on if you're interested. And yeah, you can always ask whatever comes to mind. If you have a question, it is highly probable that someone else has it as well. They just don't want to ask it. So any questions before we go on?
I have a simple question. I've read about the three-tier architecture. Is it recognized as monolith, or it's a different thing? The monolith is one tier.
That is an amazing question. The three-tier architecture actually applies to each of these. Sorry, I switched by mistake. So the three-tier architecture, let's take an example, MVC. With MVC, you have a model, a view, and a controller. And sorry, I don't know why I think it's my mouse. Oh, okay. The wheel got stuck. Okay. Yeah. So the thing is, some people even apply 3-tier on front end on its own, and then 3-tier on the back end on its own. So you would have MVC or MVVM on the back end, and then you would have MVC or MVVM, actually MVC on the front end as examples. So it applies to the layer. You can make it, so you can apply MVC in a microservice. So each of these can be MVC. The front end can be MVC. The back end can be MVC. In serverless, the function can be MVC, but that's a code smell. There could be something wrong if you need a single function to be MVC. Now, I have had solutions where we're using shared code, so it's like a library, and that's why they're using MVC, because the library code itself is shared with the project. I wouldn't go a lot into details because like this could take a talk on its own, but the simple answer is a 3-tier architecture applies to each layer. So you can have 3-tier architecture in monolith, you can have it in microservice, and for some reason you may have it in serverless.
Thank you. It's clear now.
Okay, sure. With pleasure. Any other questions before we dive into the code?
I have a question in continuation to the previous question that I asked.
Sure. So somewhere here?
No, the same thing, the same example that I gave, right? Let's say you deploy the Express application, Node.js Express application as a complete serverless function.
Yeah.
So in that case, let's assume that I get let 2 requests or 3 requests per. So the function is hot for 25 minutes, but I am not charged for it. So it only executes for, let's say, 1 second or something,
Yes.
that API inside that express. So wouldn't that be a cheaper option then, instead of using a container which runs 24/7?
That's a tough question, to be honest. First of all, you're assuming a lot of things. You're assuming that you'll only receive 3 requests per second.
Yeah,
Sorry, per hour.
assume, yeah, according to these assumptions, yeah.
Yeah, that's one thing. And you're assuming that your code runtime is going to be the same regardless of the number of lines there are. So the thing is, as your program gets bigger, it's going to take, like, it's less optimized. Now, if these assumptions are taken for granted, then yeah, maybe it's good for your scenario, yeah. But it's really like, this would be a very, it's an exception. It's not why users go to serverless architectures for. You see what I'm saying?
Yeah, I understand that we use it for a single endpoint kind of
Like,
code thing.
look at this. I'm gonna show you an actual sample function. I should have it here somewhere. This is the function we want to code. And I'm sorry, I know we're going to go over time. Where do I have a sample function? Okay, this is the one we want to code. And again, this is a sample function. See how small it is? The thing is, you get a context and the request. The context is where you say, for example, context.log. And the request is the actual request you received. In this context, sorry, I don't mean this context. I mean this context of a function. You don't have to build something like what we did in the Node.js talk, which is this. We used to have a well, you could still have a validator in a function. You do not need the body parser. You do not need to use something like Express for routing. It's much smaller. It's meant to be nano size.
Okay, yeah.
If you do it your way, it's totally unorthodox. Would it cost you less? Probably. If you have your assumptions validated, then yes. Is it the norm? No, definitely it's not the norm.
Okay, yeah, it's clear now. Thank you.
Okay, you're welcome. Yeah. So talk is cheap. Show me the code. Any questions before we jump into the code? We kind of already jumped, but you know what I mean. Okay, no questions. So hands-on. This is probably my favorite part of this talk. And so to start with, we are going to use Azure Functions simply because my subscription with Amazon is expired. And I have credit through the company I work for, through SOTI, for Azure, and it's personal credit. It's not for the company, so I can use it for such talks. So that's why we're using Azure. Whether Azure is better than AWS or not, that's a completely different question. It's up to the use case. For my use cases, I've found that AWS is more advanced in some fronts. Doesn't mean that Amazon is always better. It's just been my experience with my special cases. So to start with, we're going to use Visual Studio Code, this guy here. And we're going to need the Azure Functions extension, which you could download from here. So that's to start with. Then we're going to create a new Azure function and tinker with the function a bit. Then we're going to connect a database. And that's, so let's dive right in. I'm going to close these files. And so once you install the Visual Studio Code, you'll have access to this IDE here. And then you install the Azure Functions extension, which adds this icon here. This is the extension. And so now we are going, I think this is an old, okay, let me restart this because it doesn't see my professional subscription VS Code. Yeah, now it sees it. Okay. So we're going to create a new Azure app, Azure Functions app. So these functions need to go into an app. The app is like the collection of all these functions and the manager for them. So we're going to create a new project. Where do I want to create it? So I'm going to browse and serverless. I'm going to make it test 3. Oh, whoops. Okay. Okay, which language do you want to use? This could be a con, by the way. Not all languages may be supported by the provider you want to work with on your serverless functions. Like, let's say someone needs something like WordPress, which allows you to create blogs easily. You cannot do that with a function. Even if there's a PHP option, it would be totally a waste of resources. So that could be a con which we did not mention before. So for now, we're going to use JavaScript, which means Node.js. It's asking you, how does this function get triggered? And for our use case, we're going to use HTTP trigger. And I'm going to call it my func. Okay. And the authorization level, is it open? Anyone can just call the function? Do you need some username, password, or some integration for authentication? Or do you want just a simple key to access the function? For our talk, I'm just going to use a key because the security is not is out of our scope. Where do you want to load it? I'm going to load it in the same window, and it's creating the project for me. So this is the sample project. It already created all of this for us. And now this is our function. You can find it inside my func folder inside the index. If you go to function.json, you'll see that I can access it through get and post. You can definitely change this. Yeah. You can see that we have a package.json. This applies to the whole app, not only to this function. So if I have multiple functions, it will install the dependencies for all of them. And you know, if you've used Node.js before, you know what these are. If you haven't, this is simply where you include the dependencies of other libraries. And it created a simple function for us, which we're going to test. Quickly, it provides you a context and the request. The request is obviously the request you received, the HTTP request. The context is something related to cloud functions. So if you wanted to log, for example, you do not have a console, so you use the context.log. So what it's doing is it's showing us that the function has run, and then it's setting a name to either the query.name, which means if we have a get request, it's going to get the name from the query, or if we have a post request, as an example, it's going to take the name from the body. So then the response message equals name, equals name with a ternary operator, which means if name is null, if name is not null, then do this. So if name exists, response message equals hello, the name, this was triggered successfully. If name is null, which means the user did not pass it, the response message will be this issue and so on. And then we're going to end our function. So we say context.resolve or response this object. The status is 200 by default, so you do not have to specify it if it's already 200. And the body is the response message. Is this code clear?
Yes, yes.
Okay, so we're going to deploy this. We're going to go to the extension again. And so while this tab is open, I'm going to Visual Studio, this one. Okay, so I'm going to deploy the function app. And I'm going to use this subscription, create new function app in Azure with defaults and globally unique name. I'm going to say serverless Steve2. Oh, no spaces. Yeah. Okay. And enter and select a runtime stack. I'm going to use Node.js 14. See, I didn't have to prepare a virtual machine and install Node.js on it and so on. It automatically asks me, what do I need? And I'll just choose 14. I'm going to make it in Canada Central. And so now it's deploying. So meanwhile, I'm going to go to Azure portal. and log into my account.
Creating any virtual machine or anything. So like, does this function get deployed in a container kind of thing internally?
Yeah, internally there is a server after all, and they have some services which manage all of this. Yeah.
But the thing is, you do not have to worry about that.
Okay, two-factor authentication. It should be done by now. It's still creating. Okay, last stage. So you see, it's taking a lot of time because it's deploying a new app. If you were just adding a function to an existing app, that would take much less. Yeah. Okay, so where's our app? It's still being created. So I'm gonna go to function app. This is what we're creating. We're creating a new function app. And so now it's not here yet. We're still waiting for the new app to get created for us. Okay, so the app is created and now it's deploying the function, and the function should be deployed very shortly. So we should be able to see it here now. I'm gonna refresh this. Yeah, this is the app. So we go inside the app, you can see a lot of stuff in here. What we care about for now is the function, and it's not deployed yet. Sometimes it takes some time for the function to show up here, even though it's already deployed. So if this here tells you it's already deployed, but this one here cannot see it, doesn't mean something failed. Maybe you just need to wait a little bit more. This is also the case with the logs. When you console.log something, it doesn't really have to be real time. Sometimes it's just delayed. Yeah, so while it's deploying, I'm just gonna show you the keys. So there are some keys for the whole app which you can configure. We really are interested in the function rather than the app. So let's go to the function. And in here, you can see that there are function keys. Yeah, the function key is what we use to access the function. So I'm gonna go back to the function homepage, the overview. So in order to access this function, I'm going to get the function URL. You can see that it has a code. And this is because, remember when I chose, it asked me if it's anonymous, admin, or function, and I chose function. And what that means is I can only access the function with this code. And when you use this mode, this code should not go into your front end. The user should not have this key. Usually you have another middleware service, such as API Gateway, for example. API Gateway would know this code, but the user needs to authenticate with the API Gateway through another kind of authentication. Anyway, security is out of scope, so just wanted to give you a hint. And now it's already deployed, and we're gonna access it using get. So it says it's pass a name. Remember the code? It did not find name in our request, so it printed this. Now, if we pass a name, so and name equals Steve, and the guys. Now it says, hello, Steve and the guys. This HTTP is okay. So is it clear? Like, we just deployed an actual function for my students. Well, actually, all of you are my students now. Yeah, okay. We lost a lot of our friends, but that's fine. So for the extra points for your prototype, it could be as simple as this, just a simple function returning some sample JSON string with the information, and that's it. So your backend can literally be done in less than 20 minutes. And by the way, both Azure and Amazon give you tons of credit for free. So you can create an account for 12 months for free. And the Azure free tier includes, I think, 400,000 gigabit second or gigabyte, I'm not sure, second throughput or credits, and some million number executions. So it's way more than you need. So I wanted to tinker with this. I don't know if you guys have some more time. Do you have some more time to tinker with this?
Yeah, I have some time. Thank you for everything.
Thank you.
Yeah,
What about
me
you?
too.
Okay, and Rajkumar?
Yeah, I have.
Okay, awesome. So let's tinker with this a bit. I wanted to go into.
So one question. So did you upload only this index.js or is there something
No,
else?
it uploaded the whole app. So what we did, we didn't modify anything actually. All we did is we went to the index, we went over the sample code it provided us. We did not do anything. We just
Okay.
created a new project and then we deployed it.
Oh, okay.
Yeah. So now let's add another function to this app. It's also HTTP triggered and we're gonna call it expenses. And it will also have a function authorization. And now it has created the function for us. As you can see, we have myfunc, which is the old sample function. And now we have another expenses function in the same app. Now in this function, I've prepared some code. I would have done it with you step by step, but it's going to take much more time. So I'll just copy and paste existing code. So I'm going to copy this pre-made code in here.
Can you just show us the contents of that myfunc directory?
So there's the function.json, which tells it how it's going to be triggered, the response function, the type, the methods allowed.
Okay.
Yeah, I don't want to go over each of these because it's really out of scope, but it's very easy for you to look it up.
Yeah, I think this is specific to Azure, right?
Yeah, it's different with every provider, but you'll find something similar though.
Okay.
Yeah, and this is the index file, which was automatically created. And now we have exactly the same files because we did not change anything yet in the new function except the index where I pasted a function I've written before. Clear?
Yes, perfect.
Okay, so now, yeah, I'm gonna show you what I'm doing here. So first we are using Monk. Monk is a library for dealing with MongoDB databases. And we're not going to use MongoDB, we're going to use Cosmos DB. But Cosmos DB, which is part of the Azure Serverless family, gives you a connector which is exactly the same as MongoDB. So as far as we're concerned, this Cosmos DB acts exactly as a MongoDB in terms of its API. So, and this is a very bad practice right here, and you'd actually lose points if you do it in your prototype for the tech innovation course. You should not include sensitive information such as this right inside the function. How this is done, you go to the app. Where's the portal? Yeah. So you go to the app and you go to configuration, and then you add it as an environment variable here. Connection string, and then you use the alias of the connection string in here. This is out of scope again for now, and part of you to look it up to get the extra points. And I don't really mind if you hack into my server, into my database right now. So, and I trust you guys, so that's fine. So I'm creating a result and I'm dealing with two different request types. Now, it really depends on your architecture. Some people prefer to have a separate function for the GET request from that of the POST request. In our case, for this talk, I'm merging them in one function. So if we receive a GET request, we're going to get the name from the query. And if there's no name, we're going to return a 400 error saying name is missing. If name is not missing, we're going to get the expense from the database. And I'm going to show you how to create this database in a second, more like a few minutes. So we're trying to find the name in this expenses collection. We had a talk previously about NoSQL. If you don't have any idea how it works, that's fine. I'm going to open RoboMongo and give you a quick hint. So if the result body length, so if there's we didn't find anything, then we return 404, your expense is another castle, not found, okay. And then we catch any error and log it and so on. And same thing for post, except that we're expecting name in the body and price. And if
one of them is missing, we return that, and then we insert the expense into the database, and that's it. Any questions regarding the code? No? Okay. So how to create a Cosmos DB instance? You can follow this link, and it's pretty quick and easy. So you just go to Cosmos. Where's the portal? You just go to Cosmos DB, and you add a new database in your portal. So you fill in the information you need, and you can follow this, and then you create a collection. So they created a collection called items, and then that's it. Basically, you go to the settings of your database, which is, in my case, I already created one, which is this. Actually, this one, the other one is expired. And from the overview, you can see, where does it give you the connection? Get a quick start. Okay, so this is my connection string, and it gives you some sample code if you're writing in Node.js, .NET, Java, Python, and so on. So yeah, so once you create it, you get this connection string, which you add to your environment variables, and then you use the alias, just like what we said before. Again, this is wrong, don't do it. Yeah, so then you add npm as a dependency, which means simply you open a terminal and you type npm I monk -- save, which adds it to the dependencies file, and press enter, and that's it. It will install monk for you, and then you'll find that the dependencies file. Oh, we actually need to do that now because okay. So we are going to do that and see how package.json doesn't have any dependencies. Once it's done, it's going to update it because we added the -- save. So, okay, this is package lock, and now this is the JSON. Now it has a monk as a dependency. Yeah, so now we can use monk in our code like this. Any questions? Okay, so you can also use RoboMongo, which was renamed to Robo3T, I believe. Yeah, Robo3T. So this is a link on how to use Robo3T with Cosmos DB if you're interested. And I'm just gonna show you our database quickly. Oh, whoops. Oh yeah, this is the expired database. Okay, that's fine. So for our database, which is this one, we can see browse. Which one are we using? Okay, let's try it. To be honest, my license expired yesterday, and I had to create a new one. So that's why I have one of them. Yeah, I think this is the old one. That's why. Yeah. So I need the new connector from Quick Start. And we're gonna access expenses. Okay, let's test this. We're gonna redeploy. Okay, so it was telling me that it's gonna override the old deployment, and then we'll be able to browse what's inside from here. I'm not sure which one it is, to be honest. I don't remember. What else do we need to do? Yeah, we just need to test this. So let's get the function. Oh, come on. Okay. So this is our function, and we need to get the link. Oh, we already have the link. Sorry, I'm sorry, my bad. Okay, so we're waiting for the deployment. And it's done. Yeah, so let's do this. Oh, sorry, this is the old function. I don't know why I got confused. So now we go to the functions, we go to our expenses function, and we get the link, and we don't pass anything, and it says name is missing, and this is a get request, so we're gonna add the name and name
equals test. So your expense is another castle. So we need to add a new one. I'm going to use Postman. So for those who don't know, Postman is a quick API testing tool. And yeah, you can create your endpoints and make requests. So we are going to use, I'm going to duplicate this. And I'm going to do this. And in the body, I'm going to include a name and price. And yeah, let's send. Yeah, so it was inserted into the database. Let's see it in the database. Why, how, I think. Oh, okay, it switched desktops. Okay, so now if we go to our database again, okay, so we're actually using this database. So yeah, so we have two of them. Which one is the one we created? 606, this one. So this is the one we created. It has the name and an object ID. I think both of them have the same name, yeah. So I'm gonna create a third one. Well, actually, it doesn't matter. We can just ask for that name anyway. So the name is Steve. And it should return both documents to us. So you see, it's as simple as that. It literally took us, what, 10 minutes? 10 minutes, including lots of talking on my end. Any questions?
No, it's perfect. No.
Yeah, so just one final thing before we say our goodbyes. If you go to the app, you can see your logs. How do you see your logs? So first of all, you can see the logs in Visual Studio Code. There is a way to do that. And another thing is you can run your function locally as well. You can attach it to the local node, to a local node instance. Yeah, and the third thing is to check the logs from here. You go to your function. So this is our expenses function. We go to monitor. You can, sorry, just a second. So you can monitor. So these are the requests we received, 404, 400, and 200. And you can also see the logs in real time, which is handy when you're testing, totally unusable when you're in production. So yeah, so if we make our request again, you can see the logs in real time. Again, you can run it locally as well. So if I go here and I run locally, okay, so now each function is available at its own link, and we are going to connect locally, send. Okay, and it worked. One thing to note is that even though I'm running it locally, it's still connected to the remote database. And this is why you should never do this and hard code credentials in the code. So if this was in the app environment, you would create an equivalent environment for the local runs, which is, honestly, I don't know which one it is right now. Yeah, it's this one. So you would have, this is, I think, I need to check. Yeah, local settings. Yeah, this is the one. So you'd say, for example, Cosmos DB URL. So this Cosmos DB URL, you would define it in your app and you would give it a value, and you would define it locally and give it a value, and then you would use this in your code, in your actual code. So when you run locally, it automatically switches to the local database. So that's the end of our talk. Do you have any questions?
I have one small question.
Sure, go ahead.
So let's say one function wants to call the other function. So do we just call it by the other function name, or else do we invoke it like the REST API get call, or
Excellent question. First of all, you need to understand that these functions, well, actually, I'm not sure if, yeah, no, I am sure. The thing is, each of these has its own deployment and its own endpoint to access it and so on. So yeah, you deal with it as a completely separate API unless you integrate them with an event trigger, such as like someone was like using Kinesis or using Event Bridge. Like it really depends on you how to trigger them. But yes, one needs to trigger another as a stranger caller.
Okay, got it. So even though both of them are in the same application, in this case.
Yeah, that's what I believe. Actually, I need. Okay, I never looked that up, to be honest. I don't know if there is a way, but to my knowledge, you need to deal with them as totally separate entities. I'm gonna look this up quickly. I'm now interested in this. Azure function. I've always called them as separate entities, to be honest. Azure function call another function in same app. Yeah, you need to just call the other one through the same API gateway and so on. Or by using an event trigger, which could be MQTT or Event Bridge or Kinesis or whatever applies to your solution.
Yeah, that actually makes more sense.
Yeah. Okay, any other questions? All good? Okay, thank you so much, guys, and enjoy the rest of the weekend. Have a great one.
Thank you.
Most welcome.
Thank you so much.
Like 5 hours of the week. I enjoyed it.
I'm glad you did.
Have a great weekend or rest of weekend.
Yeah, thank you. You too.